Okay, good evening, everyone. So in the last class, we discussed about the VPC and we created a VPC, right? And in the VPC is nothing but a network in which it can contain multiple subnets. All the subnets are a part of the main network, and every VPC will have an internet gateway. And internet gateway is responsible to maintain the communication with public IP and the internet. So it will maintain the information about which EC2 instances are having which IP addresses, like which public IP address. And it will establish the communication from the internet to your network and from your VPC network to the internet. And in the subnets, we have two different subnets available, public and private. In the public subnet, whatever the instances we create, you can assign a public IP and the instances are accessible from outside anywhere across the globe. And the private subnets, they will not get any public IP. If you assign any public IP also, they will not be usable. Okay, and the private subnet machines will be accessible only from your VPC only. And we created the same things, and how to create a public or private is that depends on the public route table. That depends on the public route table. So whenever you create a public any route table, that will get with a default route. So this is the default route, which will establish the communication within your VPC across all the subnets. If you have a 10 subnets also, every subnet is able to communicate with each other. And here you can see there is another route which we created. And the route is, if the destination is any IP address other than your VPC network, then the traffic should go through the internet gateway. And then we will associate the public subnet with the public route table. Because of the new route through the internet gateway, your subnet will get the internet. So that's how we can create the public subnet. And in the private subnet, we don't create any additional routes except the default route which we create at the time of creating the EC2 instance. So already we created this environment in our network, in our Amazon account. Let me show you quickly what exactly we created. If you log into your Amazon account and if you go to VPC, you can see your VPC called My First VPC. That's what the name we have given, right? And the IP CIDR block is 192.168.00/60. If I click on your VPC, this is the VPC which we created. This is the IP version 4 CIDR block. And this is not the default VPC. And we created two subnets, and we made one as a public and private by creating the appropriate route table and the routes. If I go to the route tables, you can see one public route table. Then where is the private route table? Yeah, default route table, which we call it as main route table. Whenever you create the VPC, the route table will be created. So this is the main route table, right? That is a route table which we are using it as a private. So to make it easily identify, what I do is under the name, I will make it as private RT, just for identification purpose. So now it is easy to identify that which route table is the public route table and which route table is the private route. Okay. So now what we do is, let me remove these IP address. Now what we are going to do is we will create EC2 instance. I will prefer Windows EC2 instance because it will have a graphical user interface. I will create two EC2 instances, one in public subnet and one in the private subnet. But before that, we have to do one more configuration on the public subnet. Generally, whenever you create any EC2 instance in the public subnet, what exactly we will expect? This must get some kind of a public IP and private IP, right? Whenever the server should be accessible from outside, then only we will create that in the public subnet. And what about the private subnet? We don't expect any public IP address because that has to be maintained internally in the VPC. So here, whenever you create the new EC2 instance, by default, there is an option called auto assign public IP, which will be disabled by default. That means automatically public IP will not be assigned unless you modify the option at the time of creation. Just I will show you later. I will show you like what exactly the configuration we have to modify. I think everybody knows like how to create an EC2 instance, right? I don't create, just I will go to the create option and I will show you the configuration which we need to modify the default feature. So in the EC2, we will go to the instances. Okay, so here we will click on launch instance, right? And then we will select the AMI and then we will see all the configuration, right? Okay, just I will give some name because anyways we are not creating. You can select any AMI, that doesn't matter. And here, give me a second. So this is the place where we will decide in which network the instance to be created. So this is the default VPC, right? Default network. And what is the default option of the auto assign public IP? Enable. That's why whatever the instances you create in the public subnet, they will be automatically assigned with the public IP. Okay. So now let us try to create one EC2 instance in the custom VPC. Click on edit. So here, this is our VPC, right? My first VPC. And here I will select the public subnet. What is the auto assign public IP option? That means you don't get a public IP. So if you create with the default options, your EC2 instance will be created with public IP, without a public IP. Then you have to assign an elastic IP address manually. Or while creating, you have to come here and you have to select enable. Then public IP will be assigned. Sometimes we might overlook this feature and we can create the EC2 instance without a public IP. If you feel that you might miss this feature, we can configure by default that will be selected as an enable. Now, whenever you click there, you can see disable, right? But that can be automatically selected as an enable. So how to do that is, so here we can say configure the auto assign public IP default setting to enable on public subnet, because on private subnet we don't need. What will happen if you select public IP enable on the private subnet? Public IP will be assigned, but no use, because there is no connection with the internet gateway and there will be no communication. So we will see from which option we have to configure this particular setting. We can change the configuration of this setting. This is a one-time step. So no need to modify this option every time you create the EC2 instance. If it requires every time we need to configure this feature, that is not no use, right? We can change the option at the time of creating the EC2 instance. Okay, so let us go to our Amazon account, and where we are modifying the option on the public subnet. Where is the public subnet available? In the VPC, right? So we have to go to VPC service. You have to go to VPC service and then click on subnets. And then select the public subnet, actions, click on actions menu and then edit subnet settings. So here, what is the auto assign IP setting? It is not yet enabled, right? So select the checkbox against enable auto assign public IP version 4 address. Select the checkbox enable auto assign public IP address. and scroll down and click on save. So from now onwards, whenever you create a new EC2 instance, automatically the public IP will be enabled. Otherwise, you have to select that enable. Okay. So now let us create a two EC2 instances. That will be Windows. And let me name it as public and private. The name of the EC2 instances. I will create one EC2 instance in the public subnet and one EC2 instance in the private subnet. These are the just names. Public is a EC2 instance name. Because of the name, your servers will not be a public, or because of your names, your servers will not become a private. Just we are giving a name, and based on in which subnet we are launching or we are creating the EC2 instances, the nature of the server will be decided. So first we will create one EC2 instance in the public subnet, and then we will create in the private subnet. Okay. So how to create the EC2 instances? Go to EC2 service. And you have to make sure that you are selecting the My First VPC at the time of launching the instance. Otherwise, your EC2 instances will be created in default VPC. Okay, go to instances and click on launch instance. Name I will give as a public, or you can use anything, public instance, whatever it is. And then I will select Windows AMI. So it will select 2019. If you need 2022, you can select that also. 2022 is the latest one. And instance type, T2.micro. Key pair, you have to select. So what is the meaning of this? Where we created this this particular key pair? While we are creating the instances in the default VPC, we created those key pairs, right? So based on that, what we can say? The key pairs can be used across any VPC in the same region. You cannot use these key pairs in a different region, but you can use the key pairs in any VPC in the same region. They are not like VPC restricted. They are region specific. Okay, then click on network settings, edit, select your VPC. Subnet, I will select public subnet. So here what happened, the auto assign public IP? No need to change. By default, it will be selected as an enable. So here, can I select existing security group and can I select the previous security groups? If you remember, we created a lot of security groups, right? Okay. So if I select existing security group, and if I click on drop down, you cannot see any security group because the security groups are the VPC specific. So have you ever created a security group alone? Like instead of creating with the instance, have you ever tried creating a new security group? So what you observe? While you're creating the security group, it will ask you to select the VPC also. That means the security groups are VPC specific. If you create one security group in one VPC1, that cannot be used in any other VPC. So what we have to do is we have to create a new security group. So I will use the name as Windows RDP because I'm going to allow RDP traffic from that security group. Then automatically it will select the RDP because it's a Windows server, TCP, port number, source type anywhere. So no need to change anything. Then just scroll down and click on launch instance. So EC2 instance will be created in public subnet. While it is getting created, let us create one more instance in private subnet. So let me click on launch instance. The same process we have to repeat, but the only difference is the subnet, we have to select the private subnet. Select Windows, instance type t2.micro. The key pair, you can select any of your key pair. And I selected private subnet. Automatically, public IP will be disabled. Even if you enable, it cannot be used. A public IP will be assigned, but you cannot use that public IP to log in. So I don't want to create any security group because just a few minutes back we created one. I will use that one. And then click on launch instance. So 2 EC2 instances are getting created. If you don't see, just click on refresh button. So let us note down the details. First, let me note down the details of the public EC2 instance. That means the instance which we created in the public subnet. So what we do is we will see how to log in. Like we will log into both the instances and we will check that whether are we able to browse the internet or not also. So here log into the public subnet EC2 instance, which is the name as public, and check the internet browsing. Internet browsing means if you open any browser and if you type Google or Yahoo, you should be able to load the page. And once we are done with this, we will see how to log into the private subnet and we will check whether are we able to access the internet or not. So to log into the Windows machine, what exactly we need? First, we need an IP address, and that should be a public IP address because we are not accessing from the same machine. And let us write down the private IP also. We will note down all the details, then we can decide. And then we need a username and we need a password. And we need a password. So first, let me get the public IP address of the public EC2 instance. So here is the public IP 54.152.179.1. So what is the private IP? So can you guess the IP address? At least the first three octets. 192, 168 dot 1 dot. Why 1? Why the IP address will start with 192.168.1? Because we decided for the public subnet, the IP address should be 192.168.1.0/24. Somewhere we have written, right? Here it is. What is the meaning of the /24? In that subnet, every IP address contains these 3 digits as a common. They will not change. That's why the private IP address will start with these 3 and the next numbers will be changed. 0 is not an IP address. 0 is a network ID and the last 4 also cannot be used as an IP address. Okay, right. So let us see what is the private IP address. And then what will be the private IP address of the private subnet instances? How it looks like? So what is the private subnet CIDR block we have given? 192.168.2.0/24. So 192.168.2 will be the common for the private instances. Okay, coming to the username. Administrator is the username. And password, just select the public EC2 instance. Click on connect, RDP client, click on get password, upload the key pair and click on decrypt password. So here we got the password. So can we use these details to log in? Yes, we can. So what exactly we are doing is to the public EC2 instance, we are trying to log in from here. Not in the VPC. We are not in the VPC. We are somewhere across the globe and we are trying to log into here. So this public subnet is having a public IP and private IP. Which IP we have to use? Can we log in using the private IP? No, because private IPs cannot be accessible over the internet. So what we have to do is we have to use the public IP address. So let me open the remote desktop connection. Let me copy the IP address. This is the IP address we have to use. Then the username is, if you got this particular window, your request is received by your server. I mean, your EC2 instance. And this is the password. Click on OK. And we are able to log into the public EC2 instance. And then what we have to check? Are we able to browse the internet or not? Okay, how to check that? We have to open a browser, and then you can use your URL like Yahoo, Google, whatever it is, and we can confirm that. And especially in the Windows servers, if you are using the Internet Explorer, for every website you are accessing, it will ask you to add that particular URL to the trusted sites. That means the website is valid website or something. Because of on Internet Explorer, there is some setting called IE enhanced security settings that will be on by default. I will show you that. That is not related to AWS. Just whenever you're trying to access any website, always it will ask you to add that particular URL to the trusted website list. Okay, open the Internet Explorer. Just wait, still the web server is booting. Okay, so here, if I do google.com, this is the one I am talking about. So this is the one. Every time, see here, content from the website listing below is being blocked by the Internet Explorer. Would you like to add this website to the trusted? That means, do you trust google.com? So you have to click on add every time. For every new URL, you have to add like this. So how can we get rid of this particular pop-up window? If you disable that security, it will not ask. So how can we disable that is, wait, it will not allow you to access any website. But we can see that internet is accessible, right? Okay. So here we have to go to server manager, click on start. You can click on server manager. And if you install a Google Chrome, it will not ask. That setting is only for the Internet Explorer. That setting will be enabled by default on all Windows servers. So once you open the server manager, on the left side, click on local server. And here there is an option called IE enhanced security configuration, which is on. The letters are too small. We cannot zoom it out. Okay, so click on that on, which is against IE enhanced security configuration, and just turn it off. So it will not block all these websites and everything. I mean, it will not ask you to add that particular website to the list of trusted websites. And still it is on. Just here, click on refresh. Make sure that it is off. Now it is off, right? Okay. So now if I open any browser, I mean Internet Explorer browser, and if I try to access yahoo.com or something, it will not ask me to add all the websites into the trusted websites. Automatically the website will be open, because I disabled that enhanced security on the Internet Explorer. That setting is only for the Internet Explorer, not for any other browser. So based on this, we can confirm that the public EC2 instance is accessible from anywhere. And in that public EC2 instance, we are able to get the internet also. We can browse the internet. Now the same thing, let us verify with the private subnet EC2 instances also. Okay, I will close it. We don't need that. Okay, so now let us log in. First thing, how to log in? how to log in? Okay, let us note down the details. So public IP, and we know that there is no public IP for the private subnet instances. Okay, first there is no public IP, and coming to the private IP. So select the private EC2 instance, and private IP is here. And you can see there is no public IP address. So this is the private IP. Username, administrator, and password. Click on connect. Same procedure. RDP client, get password, upload your key pair. Click on decrypt password. So this is the password. Now the question is how to log in. Now what we are doing here? Just we are logging in like this using private IP. Is it possible? No. Let us try first. Then we can see what is the possibilities. So let me try using the private IP address. What is IP address? 192.168.2.42. Even you don't get that particular page where you have to enter the username and password. Then what it is trying? It is trying to identify, is there any computer with this IP address in my network? If my network is the same, 192.168. something, then it will try to identify in the same network. And the EC2 instance is not in my network, right? That is somewhere in the AWS, which is running using the private IP. So we are unable to log in. Now, how to log in then? How can we log in? How to log in? And we discussed that all the subnets in the VPC are able to communicate with each other, right? That means the public instance and private instances are able to communicate with each other. For this, Amazon is providing you a concept called Bastion host. The Bastion host acts as a mediator between the private subnet and the user. So where we are creating the Bastion host? Public subnet. So it will get a public IP and it will get a private IP. So this user, he will log into the Bastion host, and from here he can log in. And this Bastion host is also called as jump server. Amazon, technically we have to use the name called Bastion host. In the real time, sometimes we call that machine as a jump server also, because nobody can communicate with the private subnet directly. So we will use a mediator machine kind of a thing, which we can use to first to jump into that machine, and from there we can access. Both are in the same network, might be two different subnets. Because of the default route, all the subnets are able to communicate with each other, right? So that's why first we have to log into the Bastion host, and from the Bastion host, you can log into the private subnet, any private subnet instance. So here you can write down a note like, we cannot log in to the private subnet instances using the private IP directly. So here Amazon is providing you a concept called Bastion host. And remember, Bastion host is nothing but a regular EC2 instance. It doesn't have any special tools or special softwares. Already we created one public EC2 instance, right? That we can call it as a Bastion host. But the purpose of the Bastion host is we don't maintain any services or any servers in that, any websites or any applications. The Bastion host is a plain operating system or a plain EC2 instance, which we can use to communicate with the private subnet machines. Bastion host is an EC2 instance available in the public subnet and which can be used to communicate with the private subnet instances. So to log in to the private subnet instance, first log into the Bastion host, and then from the Bastion host, log into the private subnet instance. And also you can note down like Bastion host is a regular EC2 instance which doesn't have any special tools or special softwares. The same AMI we will use. And the Bastion host is also known as jump server. Bastion host is also known as jump server. So now let us see, log into the private EC2 instance. So what are the two steps here? First, log into the Bastion host. Or I think, wait. Before that, first we have to create the Bastion host, right? And the Bastion host must be created in the private subnet only. Bastion host must be available in the public subnet. What will happen if you create the Bastion host in the private subnet? What will happen if you create the Bastion host or Bastion station? Both are same. What will happen if you create the Bastion host in the private subnet? First, we cannot log into the Bastion host, right? So we can ignore that. We can forget about like how to access the private instance. So create a Bastion host. Sometimes we call this as a Bastion station also, in the public subnet of my first VPC. Then log into the private subnet EC2 instance. So here we have to follow two different steps. One is log into the Bastion host, and then log in to the private EC2 instance from the Bastion host. What is the meaning of from the Bastion host? Instead of opening that remote desktop connection in your laptop, you have to open that remote desktop connection in the Bastion host. That means instead of sending the request from your laptop, we are sending the request from Bastion host to the private EC2 instance. Okay, so now let us see how to create a Bastion host. So go to your EC2 service, Click on launch instances. The same way how you create the public EC2 instance. I will give it name as a Bastion. Select Windows and make sure that you have selected the key pair, T2.micro instance type. Network, you have to select your my first VPC and the subnet to be public subnet. Then the instance will be created in the public subnet. And I will go with the select existing security group because already I have a security group which will allow RDP protocol. If you don't have the security group, you can create it. That doesn't matter. Then just scroll down and click on launch instance. Is there any difference between like a regular EC2 instance creation and Bastion host creation? No, the same AMI we use, but we don't use the Bastion host for any other purpose. If you install some website in that, and if you are using the Bastion host to communicate with the private subnets, it will consume more resources, right? Your applications will, your application performance will goes down. That's why we don't use our actual public EC2 instance to log in or to communicate with the private subnets. So obviously we need the details of the Bastion host, right? So let us note down the Bastion host details. So here, let me write down the details. So we need a public IP to log in first, and then username, administrator, and then password. How to get the password? Same process. Select the Bastion host, click on connect, RDP client, click on get password. Okay, you have to wait some time because still the status check is initializing. We have to wait for some time. So we created this one, and first from here we will log into the Bastion host, and from here we will log into the private subnet. We are using this as a jump server, and Amazon technically call this machine as Bastion host or a Bastion station. Both are same. Okay, let me check for the password. Okay, wait. It will take up to 4 minutes. Sometimes it will be available in the 2 minutes, 3 minutes, but maximum it will take 4 minutes. Okay, let me. Okay, it seems we are able to get the password. Okay, so this is the password of the Bastion host. So to access the private subnet machine, first we have to log into the Bastion host, and then we have to log into the private EC2 instance. First, let us log into the Bastion host. So let me open the remote desktop connection, and this is the public IP. Username is administrator, and here is the password. So we were able to log into the Bastion host using the public IP because it is in the public subnet. From here, you have to log into the private subnet also. What I do is just I will minimize it and I will copy the details. This is the private subnet EC2 instance details, right? Because we have to log in from the Bastion host. So I will paste these details there. So directly I can log in from there. Instead of minimizing and maximizing every time, I will maintain the details over there. So it will take some time to load the profile for the first time. Okay, so here, wait. Just I will open the notepad and I will paste the details of the private EC2 instance so that I can copy paste and all the things I can do. Okay, I think it is visible now. Okay, so right now we are in the Bastion host. This is the Bastion host. So now to log into the private subnet, you have to open the remote desktop connection in the Bastion host. So you can find somewhere here remote desktop. If you don't find it, just type a remote in the search. Click on the remote desktop connection. So what is the IP address of the private subnet machine? 192.168.2.42. And this is the password, right? Okay. Click on connect. And you can see you will be asked to enter the username and password. Once you got this box, that means your request is received by the Windows server and it is asking to authenticate by providing the credentials. Click on OK. And now we are logging in to the private EC2 instance. It seems wrong password. Okay, username is wrong. Spelling mistake. Sorry. Okay, click on yes. And we are logging in to the private subnet EC2 instance. You can see the IP address also 2.42. Or once you log in on the screen desktop also, you will get the details, right? There also you can confirm that in which computer you are doing all these things. If you minimize this, in the backend, you can see the Bastion host. Okay, I will do one thing. I will navigate like this. Wait a second. So you're asking like you would like to log in using this one, right? But this is a public instance, right? Let us say you are using this for some application. If multiple people are logging to this machine, you will use some CPU, right? Then your application performance will goes down. That's why we use a separate machine here. If you would like to, if you are not bothered about like the performance of your applications running in this public EC2 instance, you can log in here also. But definitely that will give some performance downgrade on the applications running in this EC2 instance. Okay. So this is the Bastion host. Easily you can identify on the Bastion host, you can see the notepad open. But in our private subnet, we don't open anything. We haven't opened anything. Okay. Simple thing, on the right bottom corner, you can see some exclamatory symbol at the network connection, right? Which means there is no internet. But anyways, we will confirm that by accessing a web page. So let me first, I will disable that IE enhanced configuration, because in the public instance also we have done that, right? Otherwise, continuously it will ask you to add the URLs to the trusted website list. Okay, I will click on local server. Okay, it is showing on. And let me make it off. Okay. Now it is off. Okay, so now I will open an Internet Explorer, and you can use any of your what we call that URL website. Let us try with Google first. Then we will try with Yahoo also. So let me type google.com. It will try to load and you will get an error. And in a different tab, I will try to access yahoo.com also. But you cannot get, because this machine doesn't have an internet connection. Forget about the incoming. It doesn't have an outgoing connection also. Because this machine doesn't know how to reach yahoo.com. It doesn't have any information about what is the path to reach yahoo.com website or google.com website. You can wait some time. After that, you can get page not found error or page is not accessible, such kind of error. But sometimes for the private EC2 instances, you might require internet browsing facility, right? Like my laptop is there, right? My laptop is a kind of machine running in the private subnet. Nobody can log into my laptop directly, but I am able to access the internet. So to provide the internet facility, in the private subnet, Amazon is providing you a feature called NAT, Network Address Translation. There is a feature called Network Address Translation. Okay, I think, give me a second. And we call that as NAT. So the NAT is used to share the internet across all the instances in the private subnet. And remember, this NAT doesn't provide any public IP address to your EC2 instances. The NAT doesn't provide any public IP, but it is able to share the internet with all the instances available in your private subnet. Even whenever you're using a home connection, broadband connection, whatever the Wi-Fi router or a modem you are getting, in that there will be an inbuilt NAT service running. Because of that NAT, you guys are able to get the internet across multiple machines available in your home. Not only in your home, every office will use the same NAT service, because they need to provide the internet facility to 1,000 people, right? But they cannot get 1,000 IP addresses, or they cannot get 1,000 internet connections. So how this NAT works is, so generally we will take the example of your home broadband connection. What we do, there will be an ISP, internet service provider, like Airtel, Jio, and so AC or whatever it is. Whenever you apply for an internet connection, what they do, they will provide some kind of a modem or a router, right? We can call it as a router. What they do, they will use some kind of a cable to connect their office with your home router. So here they will assign a public IP address, and the public IP address, they will create all the required things so that your router is able to communicate with the internet. And you have multiple machines in your house. Multiple machines like mobile phones, laptops, desktops, whatever it is. And what we do, we will connect all the devices to the router. Let us say 1, 2, and 3. These machines will get some kind of an IP address like 10.0.0.11. And the second machine's IP address is having like this. And third machine's IP address is like this. And this is also a network, right? So here it will have an IP address called 10.0.0.1. They might use a 192 series private IP. Just to avoid the confusion, I took a different IP address. So here in this router, by default, there is a service called NAT. So what exactly this NAT will do is, this NAT act as a mediator between the local network and the internet. Let us say you log into the computer 1 and you type google.com. And from the computer 3, you type yahoo.com. On these computers, in our home network or everywhere, there is a concept called default gateway. Even if you go to your computer and if you do IP config, so you can see there is a default gateway, right? That is my Wi-Fi router's IP address in which the NAT service is running. What is the meaning of that is, we are informing my laptop that if you would like to reach internet or anything, you have to go to that IP address. In this case, what will happen? The first computer is trying to access the google.com. So the request will go to the computer 1. The router from the computer 1. It will store the information that the 10.0.0.11 computer is requesting for google.com. And this machine is trying to access yahoo.com. The same information will be recorded like this, yahoo.com. So now what this machine will do, it will communicate with the yahoo.com server and it will communicate with the google.com server, because your Wi-Fi router or the NAT service is having the internet facility. Once it requests the google.com, it will send a response, the home page, it will send a response. Already it is storing the information about which computer is sending what request. Once it receives the response for the google.com, the same response will be forwarded to the computer 1 and the yahoo.com response will be forwarded to the computer 3. This is how the NAT will share the internet across all the machines. Okay, so the same way we have to implement the NAT service on your VPC also, if you need the internet browsing in the private subnet. And remember, the NAT service will never allow any incoming transactions. If someone is trying to access your private subnet instance, it won't allow. Only it will allow all the outgoing transactions, or in a simple terms, we can say that it will allow internet browsing. Now the question is, where to create the NAT? In the public subnet or private subnet? Okay, let us say if I create here a Bastion NAT service, then what will happen? To share the internet, first this device must have the internet connection, right? If you create the NAT service in the private subnet, the NAT instance itself will not get the internet connectivity. Then it cannot share, right? That's why you have to create the NAT in the public subnet only. I created the NAT and I configured the NAT and everything. Now, if I log into the private subnet and if I do google.com, does it able to access the google.com website? Okay, let us say here, I logged in and I type google.com. Then what will happen? In the private instance, I type google.com in the browser. What will happen? The request will go to the private RT. For google.com, there should be some IP address. So it will check all the routes and the google.com IP address doesn't fall into the default category. So it don't know how to reach the internet. So what we have to do, we have to inform your private subnet. If you would like to reach internet, internet means any IP address that will be represented with this, right? Then you have to go to NAT. Then the request will be sent to the NAT and the NAT is able to get the response. If you don't create this, you can create 1000 NAT instances, NAT services, there is no use. Once you create the NAT, you have to inform your private subnet that to browse the internet, you have to communicate with the NAT, which is available at so-and-so IP address. That is what the NAT is. In a simple terms, the NAT will share the internet with the private subnet. On an Amazon, there are two different types of NAT services available. One is NAT instance, and the second one is NAT gateway. In the real time, everyone will use the NAT gateway. Nobody will use NAT instance because the NAT gateway is a highly available, highly scalable, and highly redundant. First, we will discuss about the NAT instance, and we will create one NAT instance also. So NAT instance is an EC2 instance which contains the NAT service and the configuration. That means in that EC2 instance, if you install the NAT software and if you configure the things, then we can call that EC2 instance as a NAT instance, because the NAT services will be available as a software and a hardware also. You can buy a NAT device also. But the EC2 instance in which you can install the NAT software, that instance is called as a NAT instance. Generally, at the time of creating the NAT, any EC2 instance, we have to select the instance type, right? Instance type. So based on the instance type, you will get the network bandwidth. That means internet speed. Let us say if you create the NAT instance with T2.small, and if you have like thousands of servers, the network bandwidth is not sufficient. The internet browsing speed will be very less. These are the challenges with the NAT instance, but that we can compare at the time of creating the NAT gateway. Okay. And the NAT instance or anything, the NAT service must be created in the public subnet. Must be created in the public subnet. And AWS is providing an AMI which provide the NAT software by default in that. That means no need to download the NAT software manually and no need to install it. If you select that particular Amazon machine image, the created EC2 instance will act as a NAT instance by default. Okay, right. So now we will create one NAT instance. Create a NAT instance. And let us name it as NAT instance in the public subnet of my first VPC. That is mandatory. Public subnet is mandatory. Okay, right. So what is the operating system you will get in that EC2 instance? We don't select operating system. What we do, we will select an AMI which is related to the NAT, so that Amazon will install the operating system and it will install the softwares, configurations, everything will be done. But what is the operating system you will get? That NAT software is available on Linux operating system. Okay, so here select the AMI related to NAT service. NAT service, so that the NAT service will be pre-installed and configured, and you will get Linux OS on NAT instance. If you don't want Linux, then you have to create one Windows EC2 instance manually, and you need to find out what are the NAT softwares available in the market, and you have to purchase it, you have to download, and you have to install everything. You have to take care. Okay, so as it is a Linux OS, in the security group, which port we have to open? 22 port is mandatory, right? Because if you would like to troubleshoot something which is not required, we have to open the SSH protocol. And if you see the diagram, all the private instances are able to communicate with the NAT to reach the internet, right? So if you type the google.com, on which port the request will go to the internet? Just open the window. On which port the request will go? If you try to access yahoo.com or google.com, 80 and 443 ports, right? If I open the browser in my laptop and if I type google.com, my outgoing traffic will go on 80 or 443. But the private instances directly don't connect with the internet. The request will be sent to the NAT server, right? That means our private subnet is communicating with the NAT instance on 80 and 443 ports. So in the security group, you have to open 22 port to log into the NAT instance as admin, and you have to open 80 and 443 ports so that your private EC2 instances can communicate with the NAT instance and they will get the internet. So now we will see how to do all these things. And after that, there is one option we have to do is, once you create the NAT instance, you have to disable, there is one option called source destination check that you have to disable. Then only the NAT EC2 instance is able to share the internet with the private subnet machines. I will show you like how to disable this one. This is mandatory. Okay, so after that, we will log into the private EC2 instance and check the internet browsing. Like, are we able to access the internet or not? Even already we checked, right? If you go there, and this is the private EC2 instance, and there is no internet. There is no internet. Okay. So let us see how to create the NAT instance. Go to your EC2 service. We have to create a regular EC2 instance, but based on the AMI which you select, you will get that NAT software installed. Click on the launch instances. So here I will give a name like NAT instance. We can give any name, ABC, XYZ, that doesn't matter. Here I will click on browse more AMIs. And in the search box, I will type NAT. Click enter. It will show what is showing? No results. But where we are in the quick start AMIs. So go to the community AMIs and it will start showing all the AMIs related to the NAT. Okay. Select the first one, which is the latest one, obviously. Click on select the first one and then just scroll down. And this must be created in the My First VPC public subnet. Instance type t2.micro. Key pair name, you can select any key pair, but we don't log in. Click on edit. Select My First VPC, public subnet. Make sure that it has a public IP. And here you have to select Linux, or I can say, I will use the name as NAT. So SSH already opened, and then we have to add two more rules which will allow 80 and 443 traffic. Add security group rule, and here port range will be 80. If you don't know the number or name, in the type you can select HTTP. And then I will click on add security group rule 443. And one more thing, source type anywhere. That is mandatory, right? Anywhere. So scroll down and click on launch instance. Once the NAT instance got created, what we have to do? Again, we missed one more step. After creating this, are we able to get the internet? No, we have to create the route, right? We have to create the route. So create an additional route in the private RT. In our case, that is a main route table as below. Without creating that additional route, you cannot access the things. Okay, give me a second. So by default, how that route table looks like? Somewhere we have noted down, right? By default, the private route table looks like this. Then what we have to do is, we have to add 0000/0. Target should be NAT instance. This you have to create. It is a mandatory. We have to create it mandatory. Otherwise, your NAT instance, even though NAT instance is available, your EC2 instances will not be able to get the internet sharing from the NAT instance. This is mandatory. Once we are done with all these things, then only you will get the internet, and it is worth to check, is there an internet connection or not. Anyways, the NAT instance is getting created, right? Once it got created, we have to disable this option. No need to log in. Just directly you can disable that from the UI. That is the AWS related setting. And then we have to create this route. I think NAT gateway we cannot complete today. So tomorrow we can do the NAT gateway. We will stop after completing this NAT instance. But NAT instance, no one will use the NAT instance because it has a lot of challenges or disadvantages that we can compare with the NAT gateway. Then you can understand the things. Okay, so now let us, this is the Bastion host, right? It is ready, running. And then what is the next step? We have to disable source destination check, right? To do that, select the EC2 instance, NAT instance. Where is that? Yeah, select the NAT instance, click on actions, go to networking, and there is an option called change source destination check. Click on that. And now it is running. So select the option called stop and click on save. So that the source destination check will be stopped. It will not check from where the request is coming and from where the request is going. It will not be checked because that has to be stopped for NAT service. For the NAT service, that is mandatory to stop. By default, AWS will monitor that source destinations and all the things. Okay. So once you are done, we have to create the route. Where we have to create the route? In the route table. Where the route tables exist? VPC service. So go to the VPC. On the left side, click on the route tables. Then select your private RT, private route table. Then click on routes. Click on edit route. Add route, type 0.0.0.0/0 and don't select the target as an internet gateway. If you select the internet gateway, along with the internet, the subnet will become a public subnet. But here, there is no NAT instance, you can see, right? If you see, there is no NAT instance. But the NAT instance is nothing but a software which is available on EC2 instance, right? So you have to select the instance under the target. Click on the instance, then it will show you the list of all the EC2 instances running in that VPC. Then you have to select the NAT instance. If you select any other, you will not get the internet. Select the NAT instance and click on save. That means if you would like to access any IP address other than the VPC, you have to go through the NAT instance. That is the meaning of that particular route. Okay. So now let us go to the private subnet. This is our private subnet instance, right? So let me refresh. And you got the internet. And let me refresh the other page also. Where is this? Yahoo.com. You will get the internet. So this is how you can share the internet. So do you think that these machines got what we call that the public IP? No. That also you can verify by going back to the EC2. And just select the private EC2 instance and check the public private IP address. This is the one, right? Private. And if you refresh, and you can see there is no public IP. So now it is got connected with the NAT instance, right? Can I access this private IP address directly from here? No, which is not possible. Let me show you. Now I am doing from my laptop. Private IPs never ever be able to access directly. You cannot communicate with the private IPs directly. The only way is by using the VPN you can, but directly you cannot. That is the use of the private IP address. Private IPs are only for the internal communication within the same network. Okay. So this is how you can share the internet to the private subnet machines without assigning a public IP. But while you're creating the private subnet, just try to assign a public IP. You can assign, but it will not be usable. There is no use of assigning a public IP also. That also you can try at the time of creating the private EC2 instance. Okay. So we know that the private instance, public instance, these all are free of charge, like free tier eligible. If you create T2.micro, then what about this NAT instance? Is it chargeable? That is not chargeable because that is also an EC2 instance and we created using T2.micro. If you create other than T2.micro, then you will be chargeable. Up to 750 hours, that is a free of cost, not per instance. So here we have like 4 instances, right? If I keep throughout the month, so every instance will consume 720 hours. So total will be 4 into 720. So I will be exceeding the total 750 hours. So I will be charged. So once you're done with the practicals, always it is recommended to delete the instances. But I will keep this because tomorrow also we have to check the NAT gateway. I will keep them as is. So once we complete the NAT gateway, then we can delete. Okay. So now are you guys clear about the VPC, what we covered as of now? Or any questions? So try to do the practicals on this VPC because it will be a little bit confused. Okay, just try to do the practical. You will get clarity. Still, if you have any questions, you can ask me. Okay. All right. Any other questions? So while creating the NAT instance, we selected that auto assign public IP as enabled, right? Why? So that every time we create the EC2 instance, no need to select enable from the dropdown. Automatically, it will be select to assign the IP. Otherwise, every time you create, what we call that, you have to change that option from disable to enable. By mistakenly, if you forget to enable, you have to assign an elastic IP address. That is the problem. Okay. Okay, then. Thank you, everyone. We'll continue tomorrow.